This is GCSE Maths, and we're going to take a look at some real life graphs. Sometimes we need to use the y equals mx plus c to work out examples of stuff in real life. So you should be able to find and interpret gradients and intercepts of linear graphs. For example, plot and interpret the graph of hiring a car at 40 pounds per day plus a cost of 20p per mile. You should be able to construct and interpret linear graphs in real world context. And the general equation of straight lines up. An equation may not necessarily use y and x, but if it is a straight line, it will still be in that form. So you mightn't always have x going along here and y going up here. You know, it might be time, it might be kind of distance and things like that. There are many different styles of questions you may be asked in exam straight line graphs. The key is being able to use the information we are given to find any unknowns. So a conversion graph, here's one with miles and kilometers. How far is 20 miles in kilometers? So you would go to 20 on the miles, go up and go across and read off then that that's going to be 12.5. I often tell my classes to put in arrows to show the direction you're going. To find how far 20 kilometers is in miles, now we're going the other way. You go to the kilometer one first and go across, read off and go down, and we reckon then that's going to be about 32 miles. So just reading off information. Again, you might be asked to come up with this graph as well, given some information. Depends on the question. Distance time graphs. So distance time graphs are useful the way to represent the journey. Time is plotted on the x-axis, distance is plotted on the y-axis. Always time going along the bottom for these things. Horizontal line means the object is not moving, because as time is passing, 1 second, 2 seconds, 3 seconds, 4 seconds, the distance is staying the same, so it's not actually moving. This here means then there's going to be a constant speed if it's a straight line, or it's then kind of slowing down. The gradient tells you, sorry, it's not slowing down. The gradient of the line tells you the speed. So if you work out the gradient of the line, distance over time, then it's going to give you a speed. The steeper the line, the faster the object is traveling. So this one, because it's covering more distance in a smaller time than this one, so this one then is going to be faster than this. The average speed for the entire journey is calculated using the total distance traveled and the total time taken. So the average speed is total distance all over total time. Let's take a wee look at an example then. The distance time graph showed class 8A's journey to the zoo. They stopped for a picnic on the way to the zoo. What time did the bus leave school? To me, the bus left school. That looks, so what happens here? They stopped for a picnic on the way to the zoo. So I reckon it started going this way here, and then this is them stopped. So this must be the picnic, and then they went on then from here. So what time did they leave school? They left at 9 AM. What time did they stop for the picnic? Goodness, my eyesight isn't going to be great here, but let's try our best. So they stopped at 10 AM. How far had they travelled when they stopped for the picnic? So that's going across there. So that's 40 and that's 60. So there's your distance travelled, and we're in miles. So it's 50 miles. How long did they stop for? They stopped from 10 and then started again at 10:30. So it's 30 minutes. And then how far is the zoo from the school? So this gap doesn't matter, it's just all about this wee kind of distance here. And again, I think that has stopped at 90. So I think it's going to be 90 miles. Must have gone to Dublin. Example 2, a plumber charges a fixed call out charge and an hourly rate. The graph shows the charges for jobs up to 5 hours. What is the fixed call out charge? So if he's there for 0 hours, you're still charged £25. So it must be £25 because it keeps adding on then from there. Calculate the gradient of the line. So we need to find again a couple of places where it's going to cross. So I'm going to pick this point here because it's crossing a nice line, and I'm going to pick this point here. So let's draw a wee line on here, and we'll see, and we'll do either a rise over a run, or you can do your kind of coordinates and stuff, but I think we're going to go for rise over run in this particular case. So I'm doing that. So M, which is my gradient, which is rise over run. So how far is that going up? That's going up from 40 to 70, 40 to 70, is it? So that's 30. And then going across here is 2. And so it's then going to be gradients in 15. Give a meaning to the value in part B. £30 for 2 hours, so it's £15 then for 1 hour, so it's his rate, so it's hourly rate. Gradient is hourly rate. Okay, write down a rule to work out the total charge. So it's effectively like a y equals mx plus c. So it's y equals mx plus c, but in our case y is our charge, our gradient is 15, we've just worked that out, and then our time is here, and our y-intercept is 25. So there's my hourly rate. Calculate the total charge for a job which takes 8 hours. So we can't fit it onto this, so we're going to have to use this formula here. T is the amount of hours, so we're going to go C equals 15 upon 8 plus 25. 15 times 8 is 120, so it's then going to be £145 for an 8-hour job. It's a bargain. Another plumber charges £30 call out and £10 an hour. Not sure what that means. Draw a graph to represent this plumber on the same set of axes. So his call out charge is 30. So there's his starting point there. And then it's £10 per hour, so the gradient's 10. So what does Mr. Reed say? Mr. Reed says every time you go across 1, the gradient tells you how many you go up. So we're going to go up 10. So we're going to go across 1. Now remember, it's a scale here. It's not 1 square. It's 1 across 1 hour. Across 1, and we're at 30. So go to 40. Across 1, 50. 1 up 60. Hopefully that is a straight line. I think I've got it right. And there. That's that guy. I think that's the final question, but I'm not sure. We'll just say a wee bit about that. Yeah, it's only another unit. And from there, so another plumber calls 30 call out charge and £10 per hour. Draw a graph to represent the plumber on the same set of axes. We've done that. Just incidentally, then sometimes you might get asked this at GCSE, you know, you want who's going to be cheaper. So after 1 hour, the same price. If he's out for less than an hour, this guy's going to be dear. Otherwise, he's going to be cheaper, because it's only at the hour time that, you know, the price gets a wee bit lower. But that's the way you work those out.